discussion on reflection, refraction, image formation, uh, shifting of image, and parallel shifting of image because of a glass slab, and all these things were based on idea that our eye perceives those images. So how exactly is the system of our human eye, and how do we process those images? Let's try to understand this very briefly and at our level which you're comfortable with. The first thing which you would observe in an eye is the cornea. That cornea thing is at the outermost region of eye, which is the bulging part, just outside the eye, or rather just at the surface where the eye meets the atmosphere. Now, inside cornea, you have a fluidy substance called aqueous humor, and that aqueous humor fills the region between cornea and a crystalline lens. That crystalline lens and cornea, has something in between known as iris, which controls the amount of light entering through cornea. Now, iris is kind of a muscular diaphragm, and it has a hole called pupil. That pupil is a dark colored thing, and the reason it is dark is because it absorbs every light going into it. And if it changes the iris hole, the pupil, rather if I use a muscular diaphragm iris, I can control the amount of light entering. That is because of pupil as my light absorbing thing over there. Now, the crystalline lens is attached with ciliary muscles, and those muscles control the curvature of my crystalline lens. So I can change the focal length of that crystalline lens. Now, just after crystalline lens, you have vitreous humor, another fluid substance. And further down, if you go there, you would reach retina. And retina is the screen of the eye. All the image formation is done on the retina. And retina has rods and cones to detect the brightness of an image and the color of image. Now, the setup over here can be simplified as a converging lens. Whole setup: pupil, iris, cornea, crystalline lens, ciliary muscles, everything. Aqueous humor, vitreous humor, everything. And retina as your screen. So what's happening is you have a converging lens and a screen known as retina. The image must be formed on the retina. So your image distance is actually fixed. Only the object distance can change, right? Now, if I have already discussed that this eye over here can be thought of as a single converging lens and my retina as a screen, I can change the focal length of that eye now. That's our advantage. How? By changing the curvature of my lens. How? By ciliary muscles. So when images are to be formed on retina, because of object kept at infinity, parallel rays would enter, and when parallel rays enter a converging lens, they have to meet at a point, and that point is your focus. So in the case of infinite separation of object with my human eye over this, my distance of retina with lens is actually focus. So distance between lens and retina is equal to focus under relaxed condition, in which the image formation is such that all the light rays are being converged to the retina. And this is not the only case in which the image formation will be on retina, in all the cases. But in this particular situation, your focal length is actually that distance of retina from that crystalline lens. Now, if the objects are nearer, then what will happen is my rays won't be parallel and I'll have to converge them. So I'll have to change my focal length. I'll have to decrease my focal length, right? By that what I mean is I'll have to increase the radius of curvature, because radius of curvature is kind of oppositely, or rather in an opposite sense related to my focal length. So if I strain my muscles, ciliary muscles over here, what will happen is my lens would have a different focal length, a smaller focal length, and I can converge those rays to retina. Now, the ciliary muscles have a limitation. It cannot reduce the focal length to a very low value. So, I have a range. I can see objects from infinity very well, because this is like no strain on ciliary muscles. And when you have full strain, this is known as a near point. I mean, you cannot see images closer than this. Why? Because under this situation, your rays have to be converged, which means under this situation, focal length is minimum. And why is this limitation over focal length? Because my ciliary muscles cannot increase my radius of curvature to a very large value. So focal length can only take a minimum value, right? This is because of restriction of ciliary muscles. Restriction on the flexibility of ciliary muscles, which means a normal person should see everything between near point to infinity, but not before the near point, right? And generally what happens is the near point of a normal adult is 25 centimeters. Near point of a normal adult. I'll just write a normal adult thing over here. This is a normal adult is equal to 25 centimeters. And far point, I mean how far you can see. That is infinity. Now, with gradual aging of ciliary muscles, my ciliary muscles could lose its flexibility. If it loses its flexibility, it won't be able to decrease the focal length by much value. So my near point over here could change. It could get more than 25 centimeters. Under this situation, I won't be able to see objects closer to me. Now that becomes farsightedness. Farsightedness or hypermetropia. Under this situation, what happens is your near point shifts to some different value. This near point is sometimes known as least distance of distinct division. This D is least distance of distinct vision. So your this D thing changes. This D becomes greater than 25 centimeters. So under this situation, what happens is your light is not able to converge the length, the rays of your eyes are not able to converge the rays of light properly. So I give extra converging power to the eye. It needs extra converging lens, right? And that converging lens shifts all the images which are from the D. See, this is your infinity, this is your D. I can only see between this. So all these are invisible to me. So my converging lens would shift all these objects to here, right? So what my task is to find a lens which does this thing, 1 by V minus 1 by U. Under this situation, your U is anything, V is this D, right? Which means for the most drastic situation, your U is 25 centimeters and V is the new near point of this hypermetropic person. You can very easily find from this equation. I mean, I don't need to spoon feed you. Now, there could be one more defect, that I am not able to see objects at infinity, which means my ciliary muscles under normal state, no strain also, has so high converging power that it converges the rays before retina. So converging lens won't help me now because it's already converging. I need a diverging lens, right? So when I'm not able to see far objects, what I'm suffering from is nearsightedness. Or myopia. Under this situation, what happens is you have to understand something like infinity is not seen by me. There's a new far point for me. Let it be F. So I can only see from this F to 25 centimeters, right? So I have to shift all the images over here. This is invisible for me. So my task is for the diverging lens. I need diverging lens, right? So task for diverging lens is to put all the objects here to F so as the work is done. Most drastic situation is infinity to this F or the new far. I'll just write a far thing. New far point, new far point thing, right? Again the same formula, 1 by V minus 1 by U is equal to 1 by F. I'll write U as infinity, minus infinity, and V as my new far point. The rest thing is done.